Let us start our today's discussion. The last time we discussed about shadow paging technique, right? So here we are going to discuss ARIES recovery algorithm. Okay. Today's our topic is what? ARIES. Write about ARIES or ARIES recovery algorithm. Whatever. It is very important question for external. Okay. ARIES recovery algorithm. I start. Yeah. So ARIES recovery algorithm. See, in this ARIES recovery algorithm, we have two approaches: steal and no force approach. Steal means what, and no force means what? We'll see here. Steal means if a frame is dirty and chosen for replacement, the page it contains is returned to the disk even if the modifying transaction still alive. So steal means, so if a frame is dirty and chosen for replacement, it is going to place and the page is contains return to the disk. Okay, even if the modification transaction still in alive also, it is going to contain return to the disk. So that is called steal. And coming to no force approach. First steal approach and no force approach. For no force approach means, here the pages in the buffer pool. Buffer pool means if this buffer pool contains number of pages. Pool means a group of things, okay, which is available in one place. So buffer means temporary storage. So buffer pool means that contains the number of pages. So that are modified by the transaction are not forced to disk when the transaction is committed. So there is no force when the transaction commits. Okay, if you have any modifications in the transaction, so those transactions are not forced to disk when the transaction commits. Okay, so these are the two approaches. So first of all, what is ARIES? What is the abbreviation of ARIES? ARIES means, ARIES abbreviation is, A means A for algorithms, for R means recovery, and I means isolation, E means exploiting, S means semantics. So the abbreviation of ARIES recovery algorithm. ARIES means A for algorithms, for recovery and isolation, exploiting semantics. What is the abbreviation of ARIES? This is very important question. So ARIES abbreviation is what? ARIES means algorithms for recovery and isolation, exploiting semantics. Let me repeat again. Algorithms, ARIES means algorithms for recovery and isolation, exploiting semantics. Okay, so here ARIES is a recovery algorithm designed to work with no force and steal database. So it is designed to work with, no force and steal database approaches. Okay, see, the ARIES recovery procedure consists of 3 steps, 3 phases here. It contains 3 phases: analysis phase, redo phase, and undo phase. Here analysis means what? Analysis means, so here analysis means analyzing the transactions are completed or analysis means what? Analyzing here the transactions are completed or are committed or transactions are not committed. Where the pages are stored. These things in this phase you can analyze it. So what in the analysis phase, what is doing? So analyzing which transactions are completed or which transactions are stored or which transactions are committed or which transactions are not committed and where the pages are stored. Okay, where the transaction pages are stored. These things are analyzing in the analysis phase. These things are analyzing in the analysis phase. Okay, analyzing is you are understanding, right? So analyzing is which transactions are completed, which transactions stored, where that transaction stored, pages where is storing, and which transaction not stored, not committed. So these we can analyze in the analysis phase. So main thing here you need to remember. So in this analysis phase, first point is what? First point, you need to identify the dirty pages. Identify dirty pages. So what are the dirty pages? You need to find it. What are the active transactions at failure? What are the active transactions at failure? So here you need to remember two things. In this phase, identify the dirty pages. Dirty pages means which are not updated or not committed. So what we are doing in analysis phase? So analysis phase. So in this analysis phase means we are analyzing the which transactions are completed, stored, and committed, which are not committed, where the pages are storing. These things it is analyzing in this phase. And first thing here in the analysis phase, it identifies the dirty pages. First, it identifies the dirty page by using this algorithm. First, it identifies the dirty pages. What are the dirty pages available? Dirty pages means what? Which are not updated or not committed. Those are called dirty pages. Remember this point. Okay. While explaining the table and example, so that time it is useful. What are the dirty pages? Dirty pages means what? Which are not updated or not committed. Okay. And what are the active transaction at failure? That means not committed, not committed. So those data we are analyzing in this analysis phase by using this technique, analyzing it. Okay. So next, see, that's what here explained. So the analysis step identifies the T. The T means what? Updated pages, not updated pages in the buffer. Okay, and the set of transaction active at the time of crash. So so if any transaction failure, if any crash occurring while you are doing the transaction, so the set of transaction are active in the time of crash. So those we need to find. Okay, the appropriate point in the log where the redo operations will start is also determined. Okay, these things we need to determine in the analysis phase. Okay, coming to redo phase. So redo phase means, simple way I am saying for remembering purpose. So redo means checking the conditions, checking the conditions in the database, checking the conditions in the database. So redo means perform checking operation for checking the conditions in the database. So in analysis phase, what it is analyzing, so which transaction to do undo operation. In analysis phase, which transaction to undo and which pages were dirty, so we need to find. Okay, then redo LSN from which redo. These type of things we are analyzing in the analysis phase. So coming to this redo phase, we are checking the conditions in the database. That means reporting history, reporting okay. And redoing all actions from redo LSN. So in the redo phase, so what do we need to do? That means what it is doing is checking the conditions in the database. That means what it is checking, reporting history, redoing all actions from the redo LSN. Okay, and so here it is finding all operations, finding the all operation done by the database before crash. The redo, what is performing, finding operations done by database crash. These are the important points. Why I am typing here means these are the important points. So in this theory, you need to remember mainly these points. So here it redo performs find all operations done by the database before crash, and and then what it is doing, and then restore system back to the same state and before. So what it is doing in the redo phase? Redo means what? Checking the conditions in the database. That means it checking reporting history, redoing all the actions from the redo LSN. Okay, redoing all the actions from the redo LSN, and finding all operations done by the database. Finding the all operations done by the database before crash. Before crash, it is finding the all operations done by the database, and then it is restoring the system back to the same state before crash. So what are the operations we have done? So for that we are reaching that operations. Okay, the cursors will be there. That means and finding all the operations done by the database before crash and restore the system back to the same state before crash. Okay, so this is done. This is doing by the redo phase. We are doing this. Okay, after that, if about all active transactions, those are still in the active state. So here after that, here it aborts active transactions. It aborts the active transactions. Those are still in the active state. Okay, at the time of crash. That means what? At the time of crash, if it aborts all the active transactions, those are still in active. Okay, we will see with the example, then you can understand. Okay, so here the main points are understanding, right? Checking the conditions in the database. That means the reporting history, checking reporting history, redoing all actions from the redo LSN, and finding all operations, finding all operations done by the database before crash. So and then restore the system back to the same state of the before crash. Okay, then here the redo phase is actually replies updates from the log to the database. So generally this redo operation is applied to only committed transactions. The redo operation is applied to only committed transactions. And then however ARIES algorithm, this is not the case. Okay, certain information in the ARIES log will provide the start point for redo. From which redo operation or which redo operations are applied until the end of the log is reached. In addition, and in the cases will allow ARIES to determine whether the operation to be redone actually been applied to the database and hence need not be replied. Thus only the necessary redo operations are applied during the recovery. So thus only the necessary redo operations are applied during the recovery. Finally, the necessary redo operations are applied during the recovery. This is about the redo phase. Okay, need to remember these points from redo phase. These are the operations we are performing. After that, we have undo phase. Okay, now we are going to discuss about what? Which phase? Undo phase. Undo means what? Undo means scan from backward. Undo means what? Undo means scan from backward. Undo means scan from backward. That means what? We are doing rollback. We are performing rollback operation. We are performing rollback for all incomplete transactions. We are performing rollback for all incomplete transactions. Performing a rollback operation for all incomplete transactions. Okay, so here the transactions whose abort was complete earlier are not undone. What we are undoing? So the transactions whose abort was complete earlier, are not undo. We cannot undo. Okay, which operations whose abort was complete earlier. Okay, so here in this undo, see the theory. See, during the undo phase, the log is scanned backward. Transactions that were active at the time of the crash are undone in the reverse order. Okay, the information need for ARIES to accomplish its recovery procedure includes the log, the transaction table, and the dirty page table. In addition, checkpointing is used. Also used. These two tables are maintained by the transaction manager and return to log due to the checkpointing. You will see that the two tables, transaction table and the dirty table. We will see here. I will show. Okay. And see here, what are the data structures used in this ARIES algorithm? The names are given here. So the data structure, page table data structure, the T-page table data structure, page LSN data structure. LSN means log sequence number. SN means what? Log sequence number. So page log sequence number data structure, and redo log sequence number data structure, then transaction table data structure, checking point log data structures. Those data structures used in the ARIES. Here LSN stands for what? Log sequence number. LSN means what? Log sequence number. For efficient recovery, we need transaction table and the T-page table. We need transaction table and the T table. We need here two tables. First table is what? For efficient recovery, we need two tables, right? We need two tables here. First one is what? Transaction table. Second one is what? The T table. Okay, so the above two tables are maintained by the transaction manager. Here, recovery manager is generally called at the time of crash. The time of crash only the recovery manager is generally called. And here we have two tables, or the tables are maintained by the transaction manager. Okay, the transaction table contains an entry for each active transaction with information such as transaction ID, transaction status, and the LSN of most recent log record for the transaction. The transaction status, what see here, the transaction table contains entry for each active transaction, which contains an entry for each transaction. For each transaction, we have an entry, and with the information such as transaction ID, transaction status, and then LSN of most recent log recovery of the transaction. Transaction ID, transaction status, and the LSN of most recent log record for the transaction. So the transaction table contains for entry for each transaction. So for each active transaction we have entry. So with the information, so what are the information we have in this transaction table means transaction ID, transaction status, and LSN of the most recent log. Okay, LSN of the recent log. So see here in this table, you can observe the transaction ID, transaction status, and the LSN of recent log. Okay, we have three attributes: transaction ID, transaction status, and LSN. LSN means what? Log sequence number of recent log. Sequence number we need to represent here. Okay, see that example, you can understand. So see in the another side, so this is for, I said two tables, right? Transaction table and then the T table. So in this transaction table we have three attributes: transaction ID, transaction status, LSN of recent log. Coming to the T page table, so the dirty page table contains entry for each dirty page in the buffer, which includes the page ID and the LSN corresponding earliest update to the page. So page ID, LSN of earliest update to the page, earliest update. Here LSN recent log, LSN of recent log, here LSN of earliest update to the page. It's having two attributes here for the T page table. Okay, first one is what? Page ID and LSN of earliest update to the page. Okay, so two tables, we divided into two tables. We have seen, right, transaction table and the T table. How you can analyzing, how you can redo, how you can undo, we will see here. So example, ARIES. See, we are performing ARIES algorithm here. So then example recovery in ARIES. So this is the table for log at point of crash. So log files having the point of crash when crash occurs. So the log point we can understand here. So these are the attributes: LSN number, last transaction ID, type operation type, page ID, pages, and other information. So transaction ID, pages, one transaction, one page. So number of pages, these are the pages. Page names, A, page ID C, A, B, C. These are the pages. Okay, we have three pages here, A, B, C. And the transactions T1, T2, and T3. Three transactions. Okay, we are performing three transactions, three pages. So what are the operations we are performing? Update operation and commit. Update operation and commit. See here, last transaction 001, the begin check-in point, then end the check-in point. See, for T1 transaction, the transaction T1, okay, T1 is updated in the page C. So T2 is updated in the page B. Then here we committed T1. That means T1, T2 is not committed here. T2 is not committed here. T1 is committed. T1 is the transaction. T1 is saved permanently. T1 means what? Which page? Page C. T1 page is what? C. Next, coming to this one, T3, T2, and T2. T3 is updated. Page A. T2 is updated in page C. So then T2 is committed. That means the T2 operation is permanently saved. Here that means finally the T1 is committed and T2 is committed, T3 in progress. Okay. So if any crash point occurs there, it is going to undo. So see here. So how here you need to analyze it and perform redo and undo operations, right? So how you can analyze? You are dividing into two tables. First one, transaction table and the dirty page table. We are dividing into two tables. What are those? Transaction table and dirty page table. What are the attributes in the transaction table? Last LSN, log sequence number, last LSN and the status. Coming to dirty page table, what are the attributes? Page ID and last sequence number, log sequence number. So page ID, log sequence number. So these are the attributes here. Coming see here, the transaction IDs. First transaction T1 and T2. T1 last LSN is what? T1 last LS1 is what? T1 last LS1. Are you getting? T1 first LS1, this one. Sorry, first LS1, this one. And where T1 is available? Last, finally, T1 is here, right? So the T1 LS1 is 3. Last T1 transaction LS1 is what? 3. Okay. Then second transaction. T2 is second transaction. So now T2 is updated, not committed. T1 is committed, right? T1 is committed here. T1 is committed. The status is committed. Coming to T2 transaction, T2 is updated. For here, it is not committed. So now the T2 is in progress. So the T2 last LSN is what? T2 last LS1. T1 first. Sorry, T2 first. Then T2 last. Sorry, T2 last. This one, right? Okay, T2 last. Where is T2 last? T2 last. That is T2. So it is in progress. In progress. This is in this way we can design the transaction table. After that, we need to find the dirty page table. Dirty page table means it contains the page ID and last log sequence number. So here for T1, what is the page ID? For T1 page ID is what? C. Okay, C for C page. Last LSN is 1. Okay. Next for T2, for transaction T2. So what is the page ID? Transaction T2. Page ID is B. Page ID is. Then last LSN T2. Last LSN was 2. So in this way we divided transaction table and dirty page table. Next transaction under dirty page table for 3 transactions. Next operation. So T1 same thing. T1 the last LSN1. For T1 the last LSN is 3. Okay, the last LSN1 3. Next for and T1 is committed. Next T2 transaction T2. For transaction T2 the last LSN is what? The transaction T2 the last LSN 8. Okay, then T2 is committed here. T2 is committed here. Next T3. So transaction T3. So the transaction T3 is in progress. So the last LSN is what? This one 6. That's what. That is in the progress. Now say that dirty table for transaction T1 which page? C page. Transaction T2 B page. Transaction T3 transaction 3 A page. So last log sequence number is what for C? 1. Okay. For B base 2. For A base 6. So this is the transaction and dirty page table after analysis phase. This is the transaction and dirty page table at the time of checkpoint. This is after analysis, and this is log at the point of crash. So these are the tables. So here the ARIES algorithm consists of the following. So writing a begin checkpoint regard to the log, writing end checkpoint regard to the log, and writing LSN of begin checkpoint regard to the specific file. So finally, what are the advantages of this algorithm? Okay, what are the advantages? First one is simple and flexible. It is simple and flexible. Next advantage is it supports concurrency control protocol. Supports concurrency control protocol. Next, the third point, third advantage, it is independent recovery of each page. It is independent recovery of each page. Okay, so these are the advantages we can see. Okay, remember, these are the important advantages from ARIES algorithm, ARIES technique. Okay, are you getting? So what are the advantages from ARIES algorithm? So it is simple and flexible, and it supports concurrency control protocol, and it is independent recovery of each page, and it is independent recovery of each page. So these are the main advantages of ARIES algorithm. So these are the points you need to remember here. Okay, all of you, are you getting? This is very, very important technique, ARIES recovery algorithm. Okay, so we have two approaches, steal and no force approach, and this contains the 3 phases. So analysis, redo, and undo phase. So ARIES means algorithms for recovery exploration exploiting semantics. Okay, so with this diagram you can explain it. This write 2 tables and explain this theory, and so write example. So log point crash, and so transaction and the dirty page table at the time of checkpoint, transaction and dirty page table after analyzing phase. So you need to draw like this, and you need to explain the ARIES algorithm. So what are the advantages from ARIES algorithm? It is simple and flexible, and it supports concurrency control protocol, and it is independent recovery of each page. Okay, that's all about today's session. We'll see next topic in the next session.